Let's now continue following the Data Explorer's motto of visualize, visualize, visualize. We have some prediction classes. We have some labels we'd like to compare them to. You can compare them visually. It looks like our model is doing pretty good. But since we're making predictions on images, let's plot those images along with the predictions. So I'm going to write some code here to plot the predictions. I'm going to create a matplotlib figure. I'm going to set the fig size to 9 and 9 because we've got 9 random samples. You could, of course, change this to however many you want. I just found that a 3x3 plot works pretty good in practice. And I'm going to set n rows. So for my matplotlib plot, I want 3 rows and I want 3 columns. And so I'm going to enumerate through the samples in test samples. And then I'm going to create a subplot for each sample. So create a subplot, because this is going to create a subplot because it's within the loop. Each time it goes through a new sample, create a subplot of n rows and cols, and the index it's going to be on is going to be I plus 1, because it can't start at 0. So we just put I plus 1 in there. What's going on here? Enumerate. Oh, excuse me. In enumerate, wonderful. So now we're going to plot the target image. We can go plot.imshow. We're going to get sample.squeeze because we need to remove the batch dimension. And then we're going to set the CMAP is equal to gray. What's this telling me up here? Oh no, that's correct. Next, we're going to find the prediction label in text form because we don't want it in numeric form. We could do that, but we want to look at things visually with human readable language, such as sandal for whatever class sandal is, whatever number class that is. So we're going to set the pred label equals class names, and we're going to index using the pred class's I value. So right now we're going to plot our sample, we're going to find its prediction, and now we're going to get the truth label. So we also want this in text form. And what is the truth label going to be? Well, the truth label is we're going to have to index using class names, and index on that using test labels I. So we're just matching up our indexes here. Finally, we're going to create a title. Create a title for the plot. And now, here's what I like to do as well. If we're getting visual, well, we might as well get really visual, right? So I think we can change the color of the title text depending if the prediction is right or wrong. So I'm going to create a title using an F string. Pred is going to be a pred label, and the truth label. We could even plot the prediction probabilities here if we wanted to. That might be an extension that you might want to try. And so here we're going to check for equality between pred and truth and change color of title text. So what I mean by this, it's going to be a lot easier to explain if we just, if in doubt, code it out. So if the pred label equals the truth label, so they're equal, I want the plot.title to be the title text, but I want the font size, well, the font size can be the same, 10. I want the color to equal green. So if they're, so green text, if prediction, same as truth, and else, I'm going to set the plot title to have title text, font size equals 10, and the color is going to be red. So does that make sense? All we're doing is we're enumerating through our test samples that we got up here, test samples that we found randomly from the test data set. And then each time we're creating a subplot, we're plotting our image, we're finding the prediction label by indexing on the class names with our pred classes value. We're getting the truth label, and we're creating a title for the plot that compares the pred label to the truth, and we're changing the color of the title text depending if the pred label is correct or not. So let's see what happens. Did we get it right? Ooh, yes we did. Oh, I'm going to do one more thing. I want to turn off the axes just so we get more real estate. I love these kind of plots. It helps that our model got all of these predictions right. So look at this. Pred, sandal, truth, sandal, pred, trouser, truth, trouser. So that's pretty darn good, right? See how, for me, I much prefer visualizing things. Numbers on a page look good, but there's nothing quite like visualizing your machine learning model's predictions, especially when it gets it right. So how about we select some different random samples up here? We could functionize this as well to do like all of this code in one hit, but that's all right. We'll be a bit hacky for now. So this is just going to randomly sample with no seed at all. So your samples might be different to mine. 9 different samples. So this time we have an ankle boot. We'll make some predictions. We'll just step through all of this code here. And oh, there we go. It got one wrong. So all of these are correct. But this is more interesting as well, is where does your model get things wrong? So it predicted a dress, but this is a coat. Now, do you think that this could be potentially a dress? To me, I could see that as being a dress, so I kind of understand where the model's coming from in there. Let's make some more random predictions. We might do 2 more of these before we move on to the next video. Oh, all correct. We're interested in getting some wrong here. So our model seems to be too good. All correct again. Okay, one more time. If we don't get any wrong, we're going on to the next video. But this is just really, oh, there we go, 2 wrong. Beautiful. So I predicted a dress, and that's a shirt. Okay, I can kind of see where the model might have stuffed up there. It's a little bit long for a shirt for me, but I can still understand that that would be a shirt. And this is a pullover, but the truth is a coat. So maybe there's some issues with the labels. And that's probably what you'll find in a lot of data sets, especially quite large ones. Just by the sheer law of large numbers, there may be some truth labels in your data sets that you work with that are wrong. And so that's why I like to compare the model's predictions versus the truth on a bunch of random samples to go, you know what, is our model's results better or worse than they actually are? And that's what visualizing helps you do, is figure out, you know what, our model is actually, it says it's good on the accuracy, but when we visualize the predictions, it's not too good, and vice versa, right? So you can keep playing around with this, try look at some more random samples by running this again. We'll do one more for good luck, and then we'll move on to the next video. We're going to go on to another way. Oh, see, this is another example. Some labels here could be confusing. And speaking of confusing, well, that's going to be a spoiler for the next video. But do you see how the prediction is a t-shirt top, but the truth is a shirt? To me, that label is kind of overlapping. Like, I don't know, what's the difference between a t-shirt and a shirt? So that's something that you'll find as you train models, is maybe your model's going to tell you about your data as well. And so we hinted that this is going to be confused. The model is confused between t-shirt, top, and shirt. How about we plot a confusion matrix in the next video? I'll see you there.